Bouveault-Blanc reduction. It's one very interesting reaction. In Bouveault-Blanc reduction, aldehydes, ketones, and esters are reduced to alcohols. Aldehydes, ketones, and esters can be comfortably reduced to alcohols in the presence of sodium and alcohol. Alcohol is a protonic solvent, so protonic solvents are required here. If you are using aprotic solvents like ether, benzene, toluene, then they favor acetylines. Acetylines are alpha hydroxy ketones. Alpha hydroxy ketones are favored if you are using aprotic solvents. So we need here protic solvent. So we are going with ethyl alcohol. So the reduction of aldehydes, ketones, and esters into alcohols is Bouveault-Blanc reduction. See these reactions. This is an aldehyde converted to alcohol. It's an ester converted to alcohol. It's a ketone converted to alcohol. The mechanism is very, very interesting. Our main interest part is mechanism only here. So as we were discussing, protonic solvents are mandatory here. Now we know that sodium contains one extra electron. In the presence of alcohol, sodium readily loses its electron. These electrons are freely moving in alcohol. In protonic solvents like alcohols, most electropositive elements like sodium, potassium, they produce solvated electrons. This point we discuss in alkali metals reaction with ammonia, or you say in the liquid ammonia, sodium, potassium, all these they lose their electrons, solvated electrons and ammoniated electrons. Because of solvated and ammoniated electrons, the solution color is blue. Those points we'll discuss there. Same lines here. These electrons are solvated electrons. These electrons act as nucleophiles here. They are going to attack, or you say add on the carbonyl carbon to form negative charge, and first radical anion is formed. We'll see the mechanism. See, for example, we have an ester, and you are using here sodium and alcohol. Sodium alcohol produces actually electron. Sodium plus ions are formed, electron is there. You can show like this. Now this electron pair is shifted here, Rc, it becomes O minus, and this electron is added to this carbon, one electron. So you can expect the same from one more sodium. It becomes O minus. Now two electrons are there. Two electrons means you can say this is like anion. When you are adding here C2H5OH, it takes one proton from there. One hydrogen is added here. Now see, this electron pair is coming back. OET is the leaving group here. OET minus is out. When it goes out, it becomes RC double bond OH. So from ester we got here aldehyde. Now the same process, two sodiums at a time I am writing. That means two electrons are going to be added here. It becomes RCO minus. It is H. Two electrons are here. Now again C2H5OH. It becomes H. It is OH. After H3O plus you can say this will be O minus, and because of H3O plus it will become alcohol. This is the mechanism. What's happening here, we'll go with again these steps. First it is the ester. We are adding electron to this carbon because the electron pair is shifted towards the oxygen, because the oxygen is more electronegative atom. Oxygen is with the negative charge now. Carbon got one electron. This one electron is given by actually sodium. Solvated electrons, or you say alcohol. electrons present in the alcohol are given to this carbon. Same step, one more electron is coming, and this is becoming like a negative charge. When you're adding alcohol, as we know that is a protonic, it produces proton, the proton is added here. And when this oxygen's negative charge coming back, OET is a good leaving group, so OET minus is out. You can show your negative charge. Then it became aldehyde now. The same steps are repeated. So two sodiums at a time, we are showing two electrons, means this oxygen is getting negative charge. You can show this is like sodium plus. Whenever oxygen negative charge is there, you can show sodium plus, no problem. And this carbon got negative charge. And when you're adding proton, this proton is added here. Still it will be O minus. When you're adding H3O plus, it will become OH. So ester is converted to alcohol. Ester converted to completely alcohol. So here, as I said, we need here protonic solvent like alcohol. Aprotic solvents like ether, benzene, toluene we should not use because they favor SLOE formation. This is Bouveault Blanc reduction. Thank you.